Hello juniors, today we're going to see electronic assignment number 6, which is a area of a triangle. We're going to learn the general formula to find the area of any type of triangle, not only right angle triangles, but for any type of triangle. Okay, so the objective for today's class, find the area of oblique and acute triangles. Okay, so I'm going to show you the demonstration of the formula to calculate the area of any triangle. Okay, as I told you, this formula is applicable for any type of triangle, either oblique or acute, or even for right angle triangles. Okay, so if you remember, the general formula for finding the area of a triangle is always area equals half of base times height, right? Or base times height divided by 2, the same thing. So this is a general formula to find the area of a triangle. Now, take a look at this triangle. This is a general triangle. It's not a right angle triangle. It's not an equilateral triangle or an isosceles triangle. It's a random general triangle, right? An escalene triangle. So, if you remember from this hint, it says A is across from angle A, B is across from angle B, and so on. So if you remember how we name a triangle, it's always the angle with capital letter, and opposite to that angle, the side with the same letter but in a lowercase letter, right? So angle A, side A. Angle B, opposite, side B. Angle C, opposite, would be side C. Okay, so remember that rule whenever you're naming triangles. Okay, so with this information, we're gonna do the following sketch in order to do a demonstration. I'm gonna trace, in this case, I'm gonna consider this side to be the base because it's the one that is in the horizontal. So I'm gonna trace the height of this triangle, which is always perpendicular to the base. Okay, so here we have 90 degrees, and I'm going to call this H, the height of the triangle, and I'm going to call this intersection over here, I'm going to call this D, okay, just in case I need this. So if you take a look, let me see, if you take a look at the area of this triangle, we write the area of this triangle by applying this formula. I told you that the base in this case is C and the height in this case is H, right? So the general formula for the area of this triangle would be half of base, which is C, times height, which is H in this case. So 1/2 CH is the area of this particular triangle. So if you take a look at triangle, let's look at triangle, this one over here, ACD. Okay, ACD is a right angle triangle. ACD triangle. So if it is a right angle triangle, because I told you that this is also 90 degrees, right? We can apply SOHCAHTOA. And by applying SOHCAHTOA, we, for example, can say that sine of this angle A is equal to opposite, which is H, over hypotenuse, which is B in this case. B is the hypotenuse of this triangle. So if I do that, I'm going to say that sine of angle A, and I remember that I can apply here SOHCAHTOA because we're talking about a right angle triangle. So this is equal to opposite, which is H, over hypotenuse, which in this case is B. Okay? So that's an important relationship here. Now, if I solve for H, I'm going to leave the H alone, right? So we're going to say that H is B times sine of angle A. Okay, now what if I replace this equivalent value, this equivalent expression of height into this general formula we wrote at the beginning? I'm gonna be getting the following. I'm gonna say that, so from this, let me show you that I'm putting this H, I'm replacing it with its equivalent value, which is all of this. Okay, so if I replace that, we're going to get the following. We're going to get that the area of the triangle is 1/2 C times, and instead of H, I'm going to write B sine of A. B sine of angle A. And you see that here we get the general formula to find the area of any triangle. It's basically 1/2. if I organize the letters, this would be BC times sine of A. And this is a general formula to find the area of any type of triangle. Right angle triangle, acute triangle, obtuse triangle, and so on. For any type of triangle. The only thing I need is two sides and the angle which is in between, okay? So in this case, side B, side C, and the angle that is in between is angle A. So with that information, if I have those three pieces of information of any type of triangle, I can find its area, okay? So here it says, the area of any triangle ABC is given by this formula. Area equals 1/2 BC sine of A. Or I can write it in many ways, right? I can say 1/2 AC sine B or 1/2 AB sine C. The important thing is that the sides, for example, if we look at this one, 1/2 AC sine B, you see that it's side, and the angle in between, okay? So it's always the two sides and the angle in between in order to be able to apply the formula. So remember that rule, okay? Let's see some examples about this. You'll see that this is quite easy. It says, A, find the area of triangle ABC. So here we have the triangle ABC, and we have two sides and the angle that is in between, right? So I can apply the formula directly here. We would say that the area, let me write this in letters first, and then we're going to replace with values. In this case, we would use a formula which is 1/2 AB times sine of C, right? So AB sine of angle C. So then I replace the values, and we're going to get that this is equal to 1/2. A is 8.4. B is 7.8. And sine of 82.7 degrees. Okay, so if we use our calculators to find the area, remember that the calculator in this case should be set in degrees, right? Because the angle is given in degrees. So if you plug in that information into your calculator, which should be set up in degrees, you should get an answer of 32.5 centimeters squared if we round it to three significant figures, okay? So this is the area of the triangle, as simple as that. It's very easy to calculate. You just need to pay attention to the information that you're provided. Let's see another case. It says the area of this triangle is 50 centimeters squared. So we're given already the area of the triangle, and we're asked to find the angle theta. So you see that we have one side, another side, and the angle which is in between, right? And we're given the value of the area. So by applying the formula, once again, we're going to use this formula. In this case, it would be, if we write it with the letters first, it would be 1/2 times F times E times sine of theta, right? This is how we should apply the formula according to this exercise. So the area is 50. 50 is equal to 1/2. F is 8.2. E is 13.7. And then we have sine of theta, which is what we want to find, right? So if I solve for this, that means I leave all of that term alone. I would take all of this dividing to the other side. With the help of the calculator, we would get that 0.89 is equal to sine of theta. Try doing this in your calculator and you should get the same answer, okay? So once we have sine of theta, I want to solve for theta. In order to leave theta alone, I would have to apply the shift sign, right? So we would say that theta is equal to shift sign, that's sine -1, sine -1 of 0.89. If you do this in the calculator, remember that your calculator must be in degrees. You would get an answer of 62.9 degrees. This would be the final answer for this exercise. Okay. So I hope this is clear. It's very easy. It's just applying the formulas, okay? Or the formula. It's actually only one formula. Now, let's do a little bit more challenging exercises, and then we're done with this electronic assignment. For this one, it says find the area of the parallelogram. So we want to find the area of all of this figure. And for that, we have this side, and this angle. If you remember the concept of a parallelogram, if you analyze its name, parallelogram means that this side is parallel to this side, and that this side is parallel to this side. And if all of those sides are parallel, it means that they must be the same, right? So if this is 12, then this is 12. And if this is 20, then this is also 20. And if this is 60, then this should also be 60. Okay, so those are things you should know by reading the name parallelogram. Okay, so how can I solve this? If I want to find the area of the whole thing, I'm thinking about that it'll be easier if I, for example, trace this diagonal over here. And you'll see that I'll get two identical triangles, right? This triangle over here and this triangle over here. So if I find the area of this triangle and then I multiply it by 2, I will get the area of the whole parallelogram, right? And I know how to calculate the area of this triangle. If I apply the formula, we would say that the area of the triangle, the first triangle, is equal to 1/2 times, we have this side, and we have the angle in between, so we can apply the formula, right? So this would be times 12 times 20 times sine of 60 degrees. Let's see if we do not use calculator, let's see if we can get to the answer. This would be area of a triangle is equal to 20 divided by 2, that's 10. 10 by 120 is by 12, sorry, it's 120 times. And if you remember from the hand trick, we know that sine of 60 degrees should be square root of 3/2. So with this information, we get that the area of the triangle is equal to 60 times √3. You can leave it like that, okay? This is centimeters squared. So once we have found the area of the triangle, we can say that the area of the parallelogram is 2 times the area of the triangle, right? So we would say that the area of the parallelogram is equal to 2 times 60 √3. So finally, the area of the parallelogram, let me erase this, is equal to 120 √3 centimeters squared. This is the area of the parallelogram if we leave it with the exact value, okay? So I think this is quite easy, right? Let's see this last example and then we're done. It says find the value of x when the area of this triangle is 5√3. So again, we're given the value of the area and we want to find the value of x, which corresponds to the sides of this triangle, right? So once again, we have one side, another side, and the angle in between. So we can apply the area formula. We're going to say that the area is equal to, well, in this case, we already have the value of the area. So if I replace let me write the formula first. 1/2 AB sine C, right, is the formula. So if we call this, for example, let's say this is AB. Let's say this is ABC triangle, then this is angle C, this would be side A, this would be side B. Okay, so if we apply the formula, this would be the area is 5√3, and this is 1/2 times A, which is x plus 2 in this case, times B, which is 2x plus 1, times sine of 60 degrees. We're not going to use calculator for this exercise, so let's see what happens. We should remember that sine of 60 degrees, if you use the hand trick, sine of 60 degrees is square root of 3/2. √3/2. Okay, so if I replace this value, for example, this 1/2, I could take it to the other side already, and I'll be multiplying by 2 basically. So we will have 10√3 here. And this is equal to, I'm going to write this term first, √3/2. And then I will have to distribute this. I will have to apply FOIL method. But before doing FOIL method here, I can take all of this term to the other side. I see that we have root 3 on top on both sides. That means that we can simplify that, right? Root 3 simplifies with root 3. And this 2, I can take it up multiplying. 2 times 10, that's 20, right? So we can say that 20 is equal to x plus 2 times 2x plus 1. Okay, after doing that, I will have to apply FOIL method. This time this, this time this, this time this, this time this, right? So I'm going to do that. I'm going to say that 20 is equal to x plus 8 times 2x, that's 2x squared. 1 times x, that's x. 2 plus 2 times 2x is 4x, and 2 times 1, that's 2. Okay, so I see that I can add like terms. So we're going to get that 20 is equal to 2x squared plus 5x plus 20 plus 2, sorry. And then I can take this 20, subtracting to the other side. So we're going to get that 0 is equal to 2x squared plus 5x minus 18. Okay, so remember we're not allowed to use calculator. I see that we have a quadratic function here. So I will have to apply factoring case number 6 in this case because I cannot simplify any of the terms, right? So if I apply case 6, you should remember this case already right now. So we would say that this is equal to, let me do case 6 here. This is 2x squared plus 5 times 2x, and then we multiply 18 times 2, that's negative 36. And since we multiplied all of the expression by 2, we need to divide all of the expression by 2 as well. Okay, so I see that here I can apply case 5 already. So this is 0 equals, and we have two parentheses, 2x and 2x. A pair of values that multiply give me negative 36, and that added will give me 5. I'm thinking about a positive 9 and negative 4, right? And remember, all of this is being divided by 2. Okay, so I see that, for example, in this parenthesis over here, I can take out a common factor of 2, which will simplify with this 2 over here. So I'm going to do that. 0 is equal to 2x plus 9 times 2 times x minus 2. All of this is being divided by 2. So I see that the 2's simplify, this one with this one. So we get the two results here. 0 is equal to 2x plus 9 times x minus 2. So one possible value of x would be if we set this to 0. Let's see, 0 is equal to 2x plus 1, plus 9, sorry. So we will get that negative 9 over 2 is one possible value of x. I'm going to write it the other way around. We're going to get that x1, the first possible value of x, is negative 9 over 2. We're talking about, there are no unit of measurement, so we're going to leave it like that. And if we set the other parenthesis to 0, we'll get that 0 is equal to x minus 2. That means that the other possible value of x is equal to 2. Okay, now we need to analyze whether both of these results are valid or if one of them is not valid. Okay, I see that, for example, this is a negative number, and this is the same as saying negative 4.5, right? If we write it in as a decimal number. So if you take a look at the graph, negative 4.5, let's see. If you take a look at this graph, you would see that if x is negative 4.5, then this side over here would be negative 4.5 plus 2, which is negative 2.5. So this side would be would have a negative value. And as you know, we can never have a negative side for a triangle, right? So for that reason, this answer, right, orange, this answer is not valid. Why? Sides cannot be negative. And for that reason, our only answer for this exercise is this one over here. Okay, so the value of x is 2. Find the value of x? Yes, so the answer is x equals 2. Okay, so I hope this was clear, juniors. I think this is quite easy. This is still a review from something you have seen last year. So I hope it was clear, and if not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention, and see you.